Hi, for day 4, what we're going to do is actually get into the similar triangle proofs. So way back in the beginning, probably day 2, we took a look and saw that there were 3 ways to prove that triangles were similar. We saw angle, angle, we saw side, 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 and then there was a big warning that this is different from congruent triangle proofs. You can't just show that the 3 pairs of corresponding sides are equal. You have to show that they reduce down to the same fraction. And then we also saw a side angle side with the same warning. When you put sides in, you have to show that they reduce down to the same fraction. So what we're going to do today is take a look at a couple of different proofs. I did give you a note sheet, so what I want you to do is take a look at that, have that out, and I'm going to do the proofs from there with you in the video. And then when we come to class tomorrow, what you'll be doing are more of those proof puzzle pieces. So you'll take a look and see how you put the proofs together, and then next week on Monday and Tuesday we'll just practice making sure that we can actually write the proofs from start to finish. Alright, so again, we'll ease into it, but I just want to make sure that you have a couple of really good examples in your notes. Okay, so for this first proof, we're going to take a look at what we want to do is figure out how to prove that these two triangles are similar. Now, we have 3 methods for proving triangles similar. We have angle, angle, side, 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 and side, angle, side. So our first challenge is to figure out which one of those methods we're going to use. So if we take a look at our 2 triangles, the first piece of given information that we have is that AB is parallel to DE. So that tells us that we don't have any information about the sides, so it has to probably be angle, angle. We have a pair of vertical angles, and if AB is parallel to DE, and we use BC as our transversal, it gives us a pair of alternate interior angles. So to write up the proof, first thing we want to do, like always, is put our givens in the proof. So we'll start off with AB is parallel to CD, and that was given. The next thing we'll do is put a pair of angles in there. We'll start off with the vertical angles, so angle BCA is equal to angle DCE, and again, the reason that we know that they are equal is because they're vertical angles. Third thing we'll put in are our alternate interior angles, so we'll say angle B is equal to angle D, and again, those are alternate interior angles. And then that's enough to say that the triangles are similar, and the reason for that would be angle, angle. Now, after you have done your first proof, just like last chapter, after you've proven that triangles are similar, you can then add an extra step. So once we prove that triangles are similar using angle, angle, side, 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 angle, side, then we can say that any of the corresponding sides are in proportion. So we'll take a look at a proof on how to do that. Alright, for our second proof, we are given that AB and AC equal 3/4 and that AE and AD equal 3/4. And then we want to prove that AB over AC is equal to BE over CD. So basically we have these 2 triangles, and before we can prove that the sides are in proportion, we first have to prove that the triangles are similar. So we're going to try to prove that triangle ABE is similar to triangle ACD. Now, for some people that's hard because one triangle is tucked inside the other, so really make sure you see those 2. Now, again, we have 3 ways to prove triangles similar: angle, angle, side, and side, side, side. So the hardest part is going to be figuring out what we have for given information. We're told that AB over AC is 3 and 4, so we can label those 3 and 4. And then AE and AD, we can label 3 and 4. And all that shows is that those sides reduce down to 3/4, and then both of those triangles share angle A, so we can use side, angle, side. So we'll put our givens in just like we start every proof. Start with the givens. Now again, those givens show that we have 2 pairs of sides that both reduce down to 3/4. So those are our 2 pairs of sides. Then we can say that angle A is equal to itself. That's reflexive. And then we can say that the 2 triangles are congruent, not congruent, sorry. We can say that the 2 triangles are similar. And our reason for that would be side, angle, side. But that's not what they want us to prove. They want us to show that AB over AC equals BE over CD, and those are sides of the triangle that are in proportion. So our last step is to say corresponding sides are in proportion. Now, we can actually go one step further, so we can actually add 2 extra steps to our proof once we've proven that they're similar. Yes, we can prove triangles similar, and yes, then we can say that corresponding sides are in proportion, but then we can go one step further. Way back in the very beginning of this chapter, I said that when you cross multiply, what you're really doing is saying that the product of the means is equal to the product of the extremes. And then we took a look at a proportion and said, okay, well, in a proportion, those things in the middle, B and C, are the means. And the things on the outside, A and D, are the means. Well, if we have a proof, and we've proven that triangles are similar, then the next thing we can do, and again, this is all order. You have to have these 3 things in the exact order. First, you prove that your triangles are similar. Then, you can say that corresponding sides are in proportion. Then, if you take that proportion and you cross multiply, you can say that the product of the means is equal to the product of the extremes. So, if you're given a proof and you see that they want you to prove that sides multiplied together equal other sides multiplied together, it's probably coming from product of the means is equal to product of the extremes. So let's see how we do one of those. All right, for the last proof that we're going to take a look at, notice that we start off with a product. That product came from a proportion. So the first thing we have to do is take the 2 things, AC and AE, and put them across from each other in the proportion, and then AC and BD across from each other. But that proportion came from having similar triangles. So for this process, we basically need 3 steps to finish off the proof. We have to prove that we have similar triangles, then we have to show that we have sides in proportion, and then we can say that when we cross multiply, we get BC times AE equals AC times BD. Now, first thing to notice is that the triangles share angle C, and then we're told that BD and AE are parallel, so that gives us a pair of corresponding angles. So quickly we can see that we're going to prove the triangle similar using angle-angle. So to write this up, first thing we want to do is put in our given BD is parallel to AE. Then we can put in one of our pairs of angles. Angle C is equal to itself, and that's reflexive. Then we can say that angle A is equal to angle B, and again, those are corresponding angles. We were told that the lines are parallel. We have a transversal, so angle A and angle B are corresponding angles. Then we can say that the triangles are similar, so triangle CBD is similar to triangle CAE. And the reason for that is going to be angle-angle. Now, once you say that triangles are similar, you can say that sides are in proportion. So BC over AE equals BD over AE. And again, that's corresponding sides are in proportion. That came from what they wanted me to prove. So I looked at what they wanted me to prove and I set it up as a proportion. Then I can put what they want me to prove, BC times AE equals AC times BD, and I got that from just cross-multiplying the proportion up above. So we say that the product of the means is equal to the product of the extremes. Now, again, order is a really big deal with this proof. Okay, make sure that your last 3 steps match mine exact.